Well, hello everyone, and welcome to the first webinar of the 2025 season sponsored by the Alaska TTAP. Our presentation today is from Dr. Jessica Garron of the International Arctic Research Center at the University of Alaska Fairbanks. She's speaking to us today on the Western Alaska Drone Community of Practice. And I have known Jessica for a number of years, and I think that you will all really enjoy her presentation today because she's very enthusiastic about her subject. So take it away, Jessica.
Thank you, Vicki, and thank you all for joining me this morning to learn a little bit more about my work with my partners across Alaska. Today, I'll be talking about some of my work with my partners with the Native Village of Unalakleet, the Model Forest Policy Program, and the Coastal Villages Region Fund. And I also would like to take a moment to point out that I am calling in today to our webinar from the traditional and unceded lands of the Lower Tanana Dene people in an area what is now known as Fairbanks, Alaska. Let's see. Let's see if we can advance the slides at all. One moment. There we go. Okay. As we know, I can't see who's on this call, but I think it's a bunch of my neighbors. So working with the assumption that we're Alaskans on this call, or at least folks that are keyed into our dynamic Alaska, we know that Alaska's climate is changing. It's becoming warmer, it's becoming wetter, and there's less ice. And we are experiencing the impacts of these changes in different ways all across the state, no matter where we live. In the North Country, pretty much from the Alaska Range north, we still have a significant amount of permafrost. And though that permafrost still exists north of the Alaska Range, it too is dynamic and is changing with our climate as well. Areas where we were able to count on the ice as an infrastructure underpinning are now rapidly thawing, causing land subsidence and impacts to infrastructure, lifestyle, and the landscape holistically across our state. So to be able to measure some of these dynamic landscape changes, one of the toolboxes, if you will, are the remote sensing tool sets. And in my case, I use the remote sensing tools that observe Earth from above it, whether or not that's a satellite, a plane, a helicopter, or a drone. I work with aerial imagery that is remotely sensed of our planet. And to choose the right tool, whether or not you want to use a drone or a plane or a satellite, or get out there and trample on the ground with your own 2 feet, is weighing a balance of questions having to do with cost and access and what the intention of your information gathering effort is. But in our Alaska, where we have very few roads and certainly even less railroads, being able to observe our state remotely using these tools has become increasingly important in in our changing Alaska, so that we can really understand what those changes are so that we can adapt to them as resilient human beings. And so, working with the different remote sensing tools, you have a different sense of scale. So, if I'm looking at a really large area, then I can use satellite data because my image of the Earth is going to be about 1 kilometer by 1 kilometer big. And the closer to the Earth I get, the higher resolution that information is. The highest resolution being me using my eye and looking at something. But drones or UAVs are pretty close to getting that high resolution data we get just by walking around in comparison. And so these tools can be used for high resolution data capture that we can use for decision making. And specifically, we can use drones to map our landscape, not just our coastlines, our subsiding permafrost, our infrastructure, but other landscape dynamics, including vegetation, animals, fire, so that we can better plan as well as make decisions in real time, whether or not that's a situational awareness for an emergency response action, or whether or not that is a decision having to do with a major adaptation decision or housing infrastructure. We all know that we are in a housing crisis across Alaska, and to be able to effectively site those new homes in places that will be resilient and sustainable in our dynamic Alaska is a challenge. Drones can help create the maps to help us make those choices for the real world applications that we need to be applying science for decision making. So I mentioned, we were able to use drones for emergency response, situational awareness, as well as planning for housing. But what we also discovered in our work over the last several years was the value of using these tools in support of search and rescue activities in remote Alaska as well. We our team particularly works with optical imagery and infrared being one of what one might call white hot or rainbow hot. And what we have come to understand that it's not just the mapping capabilities that are critical to our neighbors in Western Alaska using these tools. It's using these tools for their full capabilities to include finding lost people and supporting questions having to do with infrastructure that I'm thinking specifically of ice roads. But this is the type of the information that we get once we collect this drone data and we process it. So if we're interested in the baseline conditions and the changing conditions of our landscape and our coastlines, we can use these tools to get 1.5 centimeter resolution images of our Alaska so that we can map entire communities for holistic planning. Or like here in the center image on our screen, this is a river that is the community's water source. And this image was collected after Typhoon Merbok when that community was concerned about potential inundation as well as physical debris, marine debris from the storm going upriver into their water source. We were able to map that source and identify that there wasn't anything in that water. On the far right, this is an estuarian type environment also in Western Alaska that we were mapping for planning for oil spills and how they would get tackled if there was one in this area. We use these data for infrastructure inspection. Time 1 and time 2, the type of data processing we do is very straightforward. I call it 3-click processing. We download the drone imagery, upload it to the cloud processing environment, 3 clicks, and then we have fully processed imagery from our drones so that we can provide that to our neighbors, our partners, and decision makers. And that also allows us to look at infrastructure over time. Another component of our work is the 3D infrastructure modeling. So the particular aircraft that we use is the Skydio X2, X10, and the S2 Plus sets of small drones. Those USA made aircraft are the quadcopter variety and allow us to hover as well as do 3D visual collections of information so that an individual picture like you're seeing here on the left can be captured with hundreds of others like you see in the top with the blue triangles to create a 3D model of physical infrastructure in remote Alaska. In this case, we were supporting the community and the Coast Guard to map essentially a tank farm, so that we could see if there was any significant damage or if it required any notable maintenance. Drones can also be used for safety applications. I briefly mentioned ice roads. Uh, the Kuskokwim Ice Road and the team which maintains it is a fantastic team, and one which has experimented with drones in support of their operations. I unfortunately have not been able to secure funding to work directly with that team, though I've spent a lot of time talking with the team and different members of that Ice Roads team under Mr. Leary's leadership out of Bethel. But the true life applications of drone in support of transportation infrastructure, when we're talking about using trails and rivers as and the ocean as our primary modes of transportation, is critical and obvious. And I hope that this image can help demonstrate the different types of ice we can differentiate just from an optical sensor and an infrared sensor captured in one image at a confluence of the Nenana and Tanana River. So the safety implications of being able to fly drones in support of our route planning is definitely significant. Several other projects out of UAF are working on the importance of remote sensing for those type of applications. And so our team has been working on a lot of stuff and did a deep dive on the feasibility of using drones for local decision making, specifically in Alaska, to synthesize that data with online climate tools, and whether or not that was realistic. And what we found was that it very much was. It was very much cost effective. And we did a study. We looked at 9 different scientific study areas and how those study areas would benefit from using the remote sensing tool unmanned aircraft for answering science questions about our changing climate in Alaska that we weren't able to access easily before. What we also discovered was the value of using these maps for all of the planning documents, insurance documents, and grant proposals that folks in Alaska are required to write in order to obtain the funding to survive and maintain basic infrastructure in rural Alaska. Part of that effort also involved looking at a breakdown of different types of aircraft and sensors. And I apologize that I didn't have time to update this slide, but I want to be clear about something. I do not endorse the DJI UAV platform in any kind of way. I made a price comparison graph using commonly operated aircraft so that folks would understand the different costing and price point levels. I do not use Chinese made aircraft. I do not support the use of Chinese made drone aircraft for flights in our Alaska. And I do use all USA made aircraft and encourage all of my neighbors to make the investment in USA made aircraft so that we can maintain a cyber secure Alaska. That project was actually the beginning of a long relationship. That feasibility project of using drones in Alaska to monitor climate change, a long relationship that I continue to this day with my partner John Henry in the native village of Unalakleet. That work represented here on this timeline with our first project representing that 2018 to 22 timeframe was actually operating in parallel with some of my other work with my partners at U.S. Coast Guard. And it became clear that the Department of Homeland Security mission and that of Tribal Alaska is very much intertwined, and that the work monitoring our infrastructure and our changing landscape and supporting search and rescue operations was more than intertwined. It was the same work being done by different people. And so that's when we started to unite our efforts, and we're funded by the Department of Homeland Security Center of Excellence, ADAC, ADAC 1.0, if you will, out of the University of Alaska, Anchorage, to develop the Remote Uncrewed Aircraft System Inspection Team in Unalakleet that was contracted for mapping by the U.S. Coast Guard, and that became a critical member of the response team during Typhoon Merbok. We now have stepped forward in time and are currently funded to expand that drone community of practice in the Bering Strait region in support of the Homeland Security enterprise. And I'm going to step through some of the specifics of that work, because this is a real brunt of our efforts in the Bering Strait region since 2018. So as mentioned, we were funded by the Department of Homeland Security to develop a drone team in Unalakleet and the standard operating procedures and flight protocols to maintain that effective team. We also conducted a second feasibility study looking at whether or not this was an effective program and how to transfer that out to other Homeland Security entities and tribes. And so that community of practice, our community of practice, was birthed then. I would say at the conclusion of 2020 is when we wrapped up that effort. And those pilots were trained to operate these USA-made drones. I use the Skydio fleet exclusively. The hardware we use is identified here with the addition of the X10, their newest quadcopter that also has night sense vision, as well as several other really fabulous features. But anyway, our drone pilots out of Unalakleet are trained to fly these different Skydio aircraft and to process the images collected with that aircraft in post-processing software, Drone Deploy, Pix4D, and Drone to Map. This team is trained on how to manage those data and to share those data, but very specifically, how to safely and legally collect those data as FAA certified pilots that have co-developed the protocols that they are actually using to make these 2D maps and 3D models, and to deliver that information to other emergency response entities, including Coast Guard, NOAA, and UAF for archival. Did all of that work, was contracted on a mission with Coast Guard 1 week prior to the impacts of Typhoon Merbok. And because we were directly operating in that space, happened to be actually out of Nome the week before Merbok hit. Our team, UAF team, Native Village of Unalakleet, an association of village council presidents. One of our pilots moved from Unalakleet out to Bethel. And so AVCP became part of our community of practice. We were funded directly by US Coast Guard and then by FEMA to collect the first imagery available in the incident command post after the impact of Typhoon Merbok. The reason why there was not other imagery available was that the weather continued to obscure the satellites that were used later on in the response for measuring the recovery need. And because there were Chinese ships in our American waters within 24 hours after the conclusion of Merbok, which drew the attention of our US Coast Guard and other armed services so that they were unable to support our Alaskans because they were defending the security of our waters. So our drone team became a critical component of that response, collecting 2D images of whole communities, highly impacted areas, and the bulk fuel containing infrastructure and the state within which it was in. For comparison, this is the type of data that that folks work with during an emergency response for decision making. On the far left, you've got a satellite image. This happens to be over Kotzebue, but that's the the type of resolution you're going to get, the distance. Here in the middle, we have a photo taken from a C-130 by U.S. Coast Guard immediately after Typhoon Merbok concluded. And this was actually when they were dropping off the inspection teams in Nome on their flyby. They took a picture, dropped those guys off in Nome, and then they went out. That was when the call came in about the Chinese ship. And then on the far right, we've got the actual drone image of the entire community. So this, I put this here for your understanding of the differences in resolution and the value of the different types of data and how you would use them for decision making. So recognizing all of this and that we had a great team, a great nugget, but we really needed to go bigger and better. We reached out to Department of Homeland Security just this past year through their newest Center of Excellence, ADAC Arctic, and asked, could you support the expansion of this drone community of practice from Unalakleet throughout the Bering Strait region? They said yes. And that's what we're working on right now, to develop this sustainable drone community of practice, or DCOP, that can perform contracted services so that we can not only provide those data to decision makers, but grow our workforce in rural Alaska and transition that training program outside of the university in this one-off project mentality into the region and the Homeland Security enterprise for a broader impact of the lessons learned on the drone training, so that we can expand not only in Alaska, but throughout Homeland Security. Our work is founded on these three pillars: sustainability, the DCOP itself, and our DCOP development team, our advisory board, our drone development team. Sustainability, the actual pilots, and the team of advisors that create a loop of information. What are the needs from the region? That comes from our DDT. What are the needs of Homeland Security coming from the DDT? What can the pilots provide? How can we train the pilots to actually meet those needs? And how do we build a foundation of sustainability so that we don't have to continue writing these one-off project grants? And so the entire work is based on transition and outreach planning, the certification of more pilots, collecting those data for those science and decision-making questions, and disseminating that data. Our current DCOP in the Bering Strait is composed of folks from all of these different communities, and we are going to be flying the X-10. So this is just a picture of the X-10 there. And we meet the DCOP pilots. We meet once a week for 2 hours, and right now we're halfway through our FAA Part 107 certification training. And those pilots will be coming to Fairbanks in March for hands-on training, FAA certification, and data processing training. But I also mentioned the criticality of sustaining this work outside of this project grant structure. And so in 2023, John Henry established the Native Village of Unalakleet Drone Services LLC, so that all members of the DCOP can be contracted through the NVU LLC if they are not already actively employed by either the village, the city, or Cowarik. There are a number of members of our DCOP pilot trainee team that work for Cowarik. IGAP coordinators, brownfield coordinators, VPSOs, all of those folks have a home on the DCOP. We're also engaging through our graduate students with FEMA, CISA, and Customs and Border Patrol about the organizational value analysis of drones for them. as well as doing a deep dive with the broader search and rescue community in Alaska about the integration of drones into their work, and learning from different mountain rescue groups from across the nation, actually not across the nation, out west in the big tall mountains, how they're using drones. We're transitioning this to our workforce training partners through, and also have developed memorandums of understanding and contracting mechanisms to support the long-term work of this team. But really, it's all about actionable science partners working together to make this happen. And so I'm expanding my actionable science partnership team. And back in 2023, started working with the Coastal Villages Region Fund. CVR or CVRF. CVRF, is, for those of you that may not know, they operate in this region highlighted here in blue. They are funded as a through the CDQ program. And in this particular case, their GIS initiative is being driven out of their Community Benefits Coordination Office, and is a 3-year investment specifically in their community benefits coordinators across this region in GIS capacity building, so that they can create maps for better decision making locally with the tribes and for the tribes. So the GIS initiative that CVRF leading is taking publicly available GIS layers, integrating the drone data, integrating highly precise GPS data and water level sensors to create these very rich maps of each community in the CVRF region to support the decisions that are going on there. Currently, as part of this effort, we have pilots in Toksook Bay, 2 pilots in Kipnuk, a pilot in Napaskiak, and a pilot in Quinnahock. And the way that partnership is working is similar to our Bering Strait drone community of practice. This team is more in the warmer areas of the YK Delta. They have already received their Part 107 certification just by doing online training and taking the exam in Anchorage. And we traveled out, the IARC team traveled out to Toksook and provided the hands-on training, where we also practiced the data collection, the processing, and management, and stepping forward using these different data sets for community applications. And again, I'd like to say that this GIS initiative is driven exclusively through CVRF by CVRF itself, and investing directly in their community members and building that capacity. Our drone work augments the work that they have already begun to be a much more holistic program full of geospatial data for decision making. But again, it's all built on actionable science partners, built on trust. I started talking to my partners at CVRF in June of 23. We didn't start actually working together until September of 24. So it takes a while to develop these trust-based relationships. But that's how we know that we are actually doing the work that we need as Alaskans, by working with our neighbors and figuring it out together and putting it into practice, by working on the land to understand our permafrost dynamics with our partners from the village, from the Coast Guard, from the university, and taking ground measurements and synthesizing those with aerial measurements collected by drones, and the predictive models and data sets coming out of different members of the University of Alaska Fairbanks to synthesize what the permafrost will likely do with drone data and ground control data, to make decisions about our Alaska with our neighbors as Alaskans as we step forward into our dynamic, ever-changing future. So with that, like to say Kayana and invite you to reach out to any of us that are doing this work in Western Alaska as part of our drone community of practice. And if you don't have time to jot down an email or a phone number, that's cool. You have Vicky's email. She'll email you again next month about the next webinar. But I want to thank you for your time and your attention. And I'd be happy to answer any questions that you may have. Thank you.
People are welcome to raise their hand or post a question in either the chat or the Q&A. And I will be happy to pass that along. Thank Jessica for her lovely presentation. It will be posted on, the recording will be posted on YouTube by hopefully tomorrow afternoon, if there are people who you know were interested in attending and were unable to attend. So, anyone have any questions? Well, if not, Jessica, do you want to roll back to the slide that had everybody's contact information? One more.
No, this one's prettier, but I will. Let me get there. Click, click. Hold on a sec. There we go.
All right. So once again, people you can reach out to regarding, if you just simply have more questions about drone applications in communities, these are definitely the people to ask questions of and talk to. But if there aren't any questions, going once, going twice. All right, I'm going to stop recording.